Now let's look at this example. Find the surface area that is generated by revolving the portion of the curve. So you are given y equal to square root x. For x between 1 and 4, so we want to revolve about the x-axis. Alright, let's sketch first. Okay. So we have y equal to square root x. Then if this is my x, this is my y. So I have here square root 1, square root 2, square root 3, square root 4. So y here is 1. So square root 2 is 1.4142. And then 1.7321. Okay. So we should have, if I have 1, 2, 3, 4, and then let's say I have 1 here. So this is 1, this is 1.4 something, this is 1.7, and then let's say I have here 2. So I should have somewhere like this, my graph. Okay. Alright. So since we talk about the surface area, and then if I revolve about the x-axis here, okay, then remember this is the symmetry, so I should have something same a reflection here, okay, on the below here. Alright, so by rotating about the x-axis, we should have something like this, geometry like this. Okay, so now we want to calculate the surface area of this or the area here. Okay, we want to calculate the surface area here given by this function y equal to square root x from 1 to 4 and rotating about the x-axis. So let's calculate by using this formula. Okay, so first we must to have our fx. So fx is x power half. So if I differentiate my fx, I should have 1 over 2 x power negative half, or 1 over 2 square root x. Then surface area given by this formula, integrate from 1 to 4, 2 pi time with your fx, okay, which is square root x, and then time with 1 plus f prime x squared, so 1 over 2 square root x square with respect to x. Okay, so before we evaluate, so we simplify first. So 1 to 4. If I bring, okay, if I bring 1 and 2x inside here, okay, so what should I have? So I bring 2 and square root x into square root, so I should have 4x, okay, 4x. And then what inside here is 1 plus, so this a square, so 1 over 4x. So simplify further, I should have 4x plus 1 dx. Okay, so now we evaluate this integral by using substitution. By using substitution or integration by substitution. So I let u equal to 4x plus 1. So du dx equal to 4. Okay. So what I want only dx. So dx equal to 1 over 4 du. Okay, so now my s equal to, so I have integrate 1 to 4 pi square root u times with 1 over 4 du. So to be easy, I bring all the constant outside. Okay, so now s equal to pi over 4. So we have u 3 over 2. Okay, now substitute back your u. Okay, remember what is our u? So this is your u. Substitute back u here. Okay. So we have pi over 6 multiply 3 times 4, 12. And then you have 2 here. So we have here is 4x plus 1 for your u power 3 over 2 from limit 1 to 4. Okay, so now we substitute the limit. Okay, upper limit first. And then lower limit. So you should have pi over 6. And then 16 plus 1 is 17, 3 over 2 minus 5, 3 over 2. If you use your calculator, so here you should have 9.8188 and then pi. Okay. So as I mentioned, you can either time with pi, so make sure in radian, or you can keep your pi and then just get your real number of this simplified value here. Alright. So the total surface area for this part is given by this value here. Alright. Okay. So if I can show you again by using Maple. So this is our problem. If I plot from square root x, y equal to square root x 1 to 4, this is more clear lah. Okay, lebih lawa lah daripada saya sketch tadi. So you have this, and then if we revolve about the x-axis here, okay, so we should have this. Okay, so we should have this geometry here. If in 3D, you will see this is the object. But since we only want to look in 2D, so if I can show you in 2D, so this is what we have in 2D. Alright. Okay, in 2D we have this. So this is your Y, this is your X. So we can calculate the surface area given by this red color here. Okay, the total area here after we rotate the curve about the x-axis, so we can calculate using the surface area formula as what we did previously. Okay, you can see here surface of revolution form y fx equal to square root x between 1 to 4 is rotated about a horizontal axis, mean about the x-axis. So this is our geometry that we have. Okay, then we calculate the surface area here by using the surface area formula. Okay, so this is what we did previously. Alright, example 3, find the area of the surface that is generated by revolving the portion of the curve y equal to x squared, x between y and 3, but now we revolve about the y-axis. Okay, so if we sketch this, so we should have this, sorry. So with 1, 3, so when x equal to 1, y equal to 1 also. And then if x equal to 3, so y equal to 9. So I have something like this, alright? Okay, so this time we revolve about the y-axis here. Okay, we revolve about the y-axis. So remember, since we talked about the azimuth symmetry, so I also have the same reflection on this part here. Alright, so in this side I should have this curve. Okay, so if we rotate, okay, so we should have some kind like this, the object here. It's like a ball, okay, ball or waist. Alright, so now we want to find the surface area represented by this geometry here. Okay, we want to calculate this surface area. Okay, so now this time we will use this formula, okay, because we revolve about the y-axis. Okay, so from the problem here, we know that y equal to x squared. So from here we get x equal to square root y. Means we have the information here, gy equal to y half. Alright, then if I differentiate g from y, I should get 1 over 2 x power negative half, or 1 over 2 square root, sorry, this should be y, square root y here. Okay, so we need to have the limit in terms of y. Okay, so at x equal to 1, so y equal to 1 square, which is 1, and then at x equal to 3, y equal to 3 square means that 9. Okay, now we can calculate the surface area here by using the formula s equal to integrate from 1 to 9 to pi. Now it's a gy, so gy is square root y times with 1 plus g prime y, which is 1 over 2 square root y square respect to y. So let's simplify first. It seems like similar like the previous problem also, but now in terms of y. Okay, never mind, we do it step by step. So 2 pi square root y. If I square this term, I should have 1 plus 1 over 4y. Then if I bring 2 and y, I bring into this square root here. So I should have pi. So 2 bring into square root become 4. Square root y bring into square root y. Okay, so it's just y, and then 1 plus Then 4y times is 1 over 4y here, dy. So now we have integrate 1 to 9 pi. So left here is 4y plus 1 dy. Okay. So now we have the ds here after we make the simplification. Okay, now we will use integrate by substitution. Okay, so by using substitution, substitution methods. Okay, so I think up to this example you are quite familiar with the integration by substitution. So we let u equal to 4y plus 1. Okay, so du dy equal to 4. What we want only, we want to know what is dy. So dy is actually 1 over 4 du. Alright. Now we substitute back into this. Okay, we simplify. So we have s equal to integrate from 1 to 9 pi. So everything here is u, and then dy is 1 over 4 du. Alright. So simplify further, s equal to pi over 4. Bring the constant outside. We just need to integrate from 1 to 9 u power half du. Then we have pi over 4. This is 4, not u. Okay. So what we have here, u 3 over 2, and then dy is 3 over 2, so 2 over 3 from 1 to 9 here. Okay, so we have here pi over 6. And then substitute back your u. Remember what is your u? Your u is 4y plus 1, so we substitute back here. Okay. It's the 4y plus 1 power 3 over 2, and then we need to substitute the limit from 1 to 9. Okay, so s equal to pi over 6. 4 times 9 plus 1 power 3 over 2 minus 4 times 1 plus 1 3 over 2. So if you calculate everything here, okay, and by using your calculator, you should get 35.6469 pi. Alright. Okay, so I write back here, sorry. So I write back here to be more clear. So this s, okay, so this s, after by using the formula, we get s equal to 35.6469 pi. Okay. Okay, if I share with you by using Maple, so this is what we have. If we plot y equal to x squared from 1 to 3, so you will have this. Okay, same what we have. Then if we rotate, okay, we rotate about the y-axis, so you should have this one. Alright, very nice. This is if you rotate at the y-axis, so you will have this something like whisk or bull. Okay, macam pasu yang sangat lawa. If I can show you, I rotate this in 3D, this is what we have. Okay, but since we want only to look in 2D, okay, so by rotating at the y-axis, so you should have this. Alright, then we can calculate all the area given by the red color here by using the surface area formula as we did before. Alright, interesting.